We live in 3 dimensions of space and 1 of time. Length, width, height, forward. It feels obvious, natural, almost inevitable, but it isn't. The universe didn't have to be this way. It could have had more dimensions, or fewer, or none that resemble what we experience. If space had only 2 dimensions, complex structures would collapse. If it had more, stability might never exist. Atoms, stars, galaxies, even cause and effect depend on the number of dimensions the universe allows. Dimensions are not just directions you can move. They define how forces spread, how matter holds together, how time can unfold. Change the number of dimensions, and reality itself changes. So the real question isn't what dimensions we live in. It's why does space have depth? Why does time move forward? And why does the universe choose a structure that allows anything to exist at all? To answer that, we have to stop thinking of dimensions as background features and start seeing them as the rules that make reality possible. Once dimensions exist, they immediately begin to shape how reality behaves. Dimensions are not just directions you can move through. They control how forces spread, how matter interacts, and how structures form. Take gravity as an example. In our universe, gravity weakens with distance in a very specific way because space has 3 dimensions. As gravity spreads outward, it dilutes across the surface of an expanding sphere, changes the number of dimensions, and that spreading changes dramatically. In fewer dimensions, forces become too strong, matter collapses too easily, stable orbits don't last. In higher dimensions, forces weaken too quickly. Matter can't hold together long enough to form complex structures. The same principle applies to electromagnetism, the force responsible for atoms, chemistry, and life. The way electric forces behave depends directly on how many dimensions space has. Alter the dimensional structure, and atoms either collapse or fly apart. This means dimensions quietly set the rules for stability. They decide whether particles can form bound systems, whether stars can burn steadily, whether galaxies can exist for billions of years. Even motion itself depends on dimensionality. The paths objects take, straight lines, curves, or orbits, are defined by the geometry of space. In the wrong number of dimensions, motion becomes chaotic or trivial. There is no middle ground where complexity survives. Matter doesn't choose how to behave. It obeys the constraints imposed by dimensions. So before physics has laws and before forces act, dimensions already determine what is possible. They act like the operating system of the universe, defining the range of outcomes long before anything actually happens. This is why dimensions matter so deeply. They are not decorations added to reality. They are the framework that allows forces and matter to interact in a way that produces structure, stability, and complexity at all. Without the right dimensions, the universe would exist, but nothing within it could last. Once forces and matter are shaped by dimensions, the next question becomes unavoidable. Which dimensions allow stability? Atoms are not guaranteed. Neither are stars, planets, or galaxies. Their existence depends on a delicate balance, one that only works in very specific dimensional conditions. In our universe, atoms are held together by electromagnetic forces that behave predictably in 3 dimensions. Electrons form stable orbits around nuclei. Energy levels are discrete. Matter can exist without collapsing or dispersing. Change the number of spatial dimensions, and that balance disappears. In the universe with fewer dimensions, forces become too intense. Electrons would spiral into nuclei. Atoms would collapse almost instantly. Chemistry, as we know it, would never begin. In a universe with more dimensions, the opposite happens. Forces weaken too quickly with distance. Electrons would not stay bound to nuclei. Atoms could not hold together long enough to form molecules. The same logic applies to gravity. In 3 dimensions, gravity allows stars to form, burn steadily, and exist for billions of years. Alter the dimensional structure, and stars either collapse rapidly or fail to ignite at all. This means complexity is not an accident. It is conditional. Only a narrow range of dimensions permits long-lived structures. Only those structures allow chemistry, and only chemistry allows information, organization, and eventually life. Dimensions don't just influence reality, they filter it. They determine which universes remain simple and which become complex, which collapse immediately, and which evolve. So when we ask why the universe has dimensions, the answer is not aesthetic or arbitrary. It's functional. The universe has this number of dimensions because this number allows stability, and stability is the prerequisite for everything that exists within it. Without the right dimensions, there are no atoms. Without atoms, there is no structure. And without structure, there is no universe worth observing. If the universe requires specific dimensions to allow stable matter and structure, it raises a final question. Are these the only dimensions that exist? Physics doesn't necessarily say yes. Some of our most advanced theories suggest that additional dimensions may exist beyond the three of space and one of time, hidden, compact, and inaccessible to everyday experience. These dimensions would not be large or open like the ones we move through. Instead, they could be tightly curled at scales far smaller than atoms. If that's the case, we wouldn't notice them directly. Motion forces and particles would be confined primarily to the dimensions we experience, while extra dimensions subtly influence how those forces behave. This idea helps explain why the fundamental forces have the strengths they do. Extra dimensions could shape how gravity spreads, why it appears so weak compared to other forces, and why physical constants take the values we observe. Importantly, these hidden dimensions wouldn't disrupt stability. They could exist without interfering with atoms, stars, or galaxies, precisely because they are compact and inaccessible at human scales. So the universe may be more dimensional than it appears, not chaotic, not unstable, but layered. What we experience could be the visible surface of a deeper structure. And that leads to a quiet conclusion. The universe may not be limited by what we can perceive, only by what remains consistent with stability and order. Our dimensions are the ones that allow existence. Others, if they exist, remain folded into the fabric of reality itself, unseen, but not impossible. The universe, it seems, may be far richer than our senses allow us to know.